Alright, Josh Green here again with MCU Lab 3. This time we're working with a double 7-segment display and getting it to show the two numbers. So first I'm going to bring you to my schematic. So my schematic here shows the AVR right here connected down to the Atmega 328P with the wires going to the resistor, which is then connected to the LED display. The only difference here is I have in parallel, I have the resistor connected to both the E and E here, the D and D there, so that way whenever I power this E, this is to power both of them. The difference is going to be here with the cathode. So as the cathode's coming out at pin 13 and 14, those are going to be connected to pin C0 and pin C1. And as I throw a high signal on one of these, it will block that digit from displaying, which becomes important in just a moment when I show you the code. So that's how we can make the display show on both sides. So here's how display works right here, showing a solid signal. And that has to do with the delay you set up between how it lights up each side, as will become apparent as we get to the code in a moment. So looking through here at my code, the code is quite similar to my previous ones. What I've done is I wrote the variables here, seg0 to seg9, and then down here I created a clear digit function as well as a write digit function. That helps in a moment. So when I come into here, I am setting the pins to output, turning the C pins to output. I'm also turning all the D pins off, and then I'm starting the timer. So how this timer works is a CTC timer. So when it reaches its interval or the comparator value, it will reset it and start over. I went ahead and prepped it for the display of 80 beats per minute. And then if I wanted it to be a solid display, like I have it down now, I'd have it set for 150. So that's how quickly it's switching back and forth. And right now it's on a prescale of 1024. So this is telling it to start the timer. Then down here, once it hits that interrupt timer, it initializes this code. So it will go ahead and if that value that's currently there, it's going to set this value of num. So that way we can preload that number, which is up here in the previous code of the function. Then it's going to clear the digit. It will go ahead and toggle the port C so that it turns off the digit, writes the new value to port D, then turns on the next digit. And that will cycle over and over and over again. So if I go ahead and build this program now, with the increased value on the comparator, we're going to see that this is now going to toggle at a rate approximately 80 beats per minute. And then I'm going to go ahead and change this a couple of things. First thing I'm going to change is I'm going to make this number become equal to its comparator. Now fortunately this is actually going to be 33 each time. I'm going to change this to 3906. That actually code with 33 probably is going to be a little bit of a loop. Hopefully it won't be too big of a problem. And we're going to have a slower toggle this time, or a faster toggle at 120 beats per minute. There it is.